Hello students, in our previous class we learned about quadratic equation, its general form and then the nature of roots. Okay, in this class we will learn some examples of quadratic equation. Okay, so let us study about some special problems depending on quadratic equation. Okay, so here we choose two problems. In the first problem, alpha and beta are the roots of the quadratic equation x square minus px plus q equals to 0, and we have to find a quadratic equation whose roots are alpha square by beta and beta square by alpha. Okay, already we know when alpha and beta are the roots of a quadratic equation, then the quadratic equation is x square minus of alpha plus beta into x plus alpha beta equals to 0. Okay, already we know this form, that is when alpha and beta are the roots of a quadratic equation, then the quadratic equation is x square minus of alpha plus beta into x plus alpha beta equals to 0. So here we have to find a quadratic equation. Solution. Given alpha beta are the roots of the quadratic equation x square minus px plus q equals to 0. Okay, we have to find a quadratic equation whose roots are alpha square by beta and beta square by alpha. So in this problem, alpha and beta are the roots of this quadratic equation x square minus px plus q equals to 0, and we have to find a quadratic equation whose roots are alpha square by beta and beta square by alpha. Then by following this form we can write the required quadratic equation is x square minus of alpha square by beta plus beta square by alpha whole into x plus alpha square by beta into beta square by alpha equals to 0. Okay. Now by following this form, our required equation will be in this way, that is x square minus of alpha square by beta plus beta square by alpha whole into x plus alpha square by beta into beta square by alpha equals to 0. Okay. So with the help of this given, that means alpha and beta are the roots of this quadratic equation, first of all we have to find alpha plus beta and alpha into beta. Again, when alpha and beta are the roots of the quadratic equation, then alpha quadratic equation ax square plus bx plus c equals to 0, then alpha plus beta equals to minus b by a and alpha into beta equals to c by a. Okay. So already we know these relations. With the help of these relations, we can find alpha plus beta and alpha into beta. Comparing the given equation x square minus px plus q equals to 0 with ax square plus bx plus c equals to 0, we get alpha plus we get a equals to 1, b equals to minus p and c equals to q. So therefore alpha plus beta equals to minus b by a imply alpha plus beta equals to minus of b means minus p and a means 1. So alpha plus beta becomes p and alpha into beta equals to c by a imply alpha into beta equals to c means q, q by 1 imply alpha into beta equals to q. Okay. So from this given quadratic equation x square minus px plus q equals to 0, we get alpha plus beta equals to p and alpha into beta equals to q. Now with the help of these two values, we have to find alpha square by beta plus beta square by alpha and alpha square by beta into beta square by alpha. Okay. Therefore, alpha square by beta plus beta square by alpha equals to, like the addition of fractions, we can add these two values, that is alpha square by beta plus beta square by alpha. Here the LCM of beta and alpha is alpha beta and in the numerator we have alpha cube plus beta cube. Already we know this identity, that is A cube plus B cube is equals to A plus B whole cube minus 3AB into A plus B. With the help of this identity, we can write alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. So alpha plus beta is equals to P. This becomes P cube minus 3 into alpha into beta is Q and alpha plus beta is P. So we get P cube minus 3PQ whole divided by Q. Okay. And alpha square by beta into beta square by alpha, we can easily cancel this alpha and this beta. After cancelling, we have alpha beta and we know alpha into beta is Q. So, product of this alpha square by beta and beta square by alpha becomes Q. Now, we can easily put these two values here. Therefore, the required quadratic we represent this form by 1. Now, from relation 1, we get x square minus of alpha square by beta plus beta square by alpha means p cube minus 3pq whole divided by q. This whole into x plus and this product becomes q. So plus q equals to 0. Okay. So this is our required quadratic equation. That means when alpha and beta are the roots of the quadratic equation x square minus px plus q equals to 0, then when we have to find a quadratic equation whose roots are alpha square by beta and beta square by alpha, then first of all we have to find the relationship between alpha beta, that is alpha plus beta and alpha into beta, and then using this relation we have to find the sum of the roots of the new quadratic equation and product of the roots of this new quadratic equation by following this way. And after putting these values, we can easily put these values in this form, and after putting we get this new form of quadratic equation, which is our required quadratic equation. Okay. In problem number 2, we have alpha beta are the roots of the quadratic equation x square minus x square equals to px plus q. Okay. So we have a quadratic equation that is x square equals to px plus q, whose roots are alpha and beta. With the help of this given condition, we have to find the value of 1 by p minus alpha whole cube plus 1 by p minus beta whole cube. Okay. Already we know every root of an equation, that equation may be a linear equation, quadratic equation, cubic equation, etc. Every root of a equation always satisfy that equation. Okay. So with that concept, okay. So before using this concept, we will check this thing with the help of an example. Here we choose a quadratic equation, that is x square minus 3x plus 2 equals to 0. And after solving this equation, we get two values of x. They are 1 and 2. Okay. So that is why we can say 1 and 2 are the roots of this quadratic equation. Okay. Now, putting x equals to 1 in the LHS of the equation x square minus 3x plus 2 equals to 0, we get 1 square minus 3 into 1 plus 2, that is 1 minus 3 plus 2. This will give 3 minus 3 equals to 0. That is RHS of the above equation. Okay. So we can say every root of an equation satisfy that equation. Okay. So this is an example. With the help of this example, we can conclude that every root of an equation satisfy that equation. Okay. So since alpha and beta are the roots of the equation x square equals to px plus q, that is x square minus px plus minus px minus q equals to 0. Therefore, alpha square minus p alpha minus q equals to 0 and beta square minus p beta minus q equals to 0. Okay. So since alpha and beta are the roots of this quadratic equation x square minus px minus q equals to 0, then we can say these two roots must satisfy that equation, and that is why we can say alpha square minus p alpha minus q equals to 0 and beta square minus p beta minus q equals to 0. Okay. This imply minus q equals to p alpha minus alpha square. This imply minus q equals to alpha into p minus alpha, taking alpha as the common factor from these two. This imply minus q by alpha equals to p minus alpha. This is number 1. Again, this imply minus q equals to p beta minus beta square. This imply minus q equals to beta into p minus beta, taking beta as the common factor from these two terms. This imply minus q by beta equals to p minus beta. Okay, this is number 2. Now 1 by p minus alpha whole cube plus 1 by p minus beta whole cube equals to 1 by minus q by alpha whole cube plus 1 by minus q by beta whole cube from 1 and 2. This imply or this equals to 1 by minus q by alpha whole cube means minus q cube by alpha cube plus 1 by minus q cube by beta cube. 1 divided by this can be written as alpha cube by minus q cube plus beta cube by minus q cube. That means reciprocal of this. Okay. So now minus q cube becomes the LCM of the denominators, and in the numerator there will be alpha cube plus beta cube. Okay. So after replacing p minus alpha by minus q by alpha and p minus beta by minus q by beta, we get alpha cube plus beta cube whole divided by minus q cube. Okay. Now we have to find alpha plus beta and alpha beta from this given relation. Okay. Again, comparing x square minus px minus q equals to 0 with ax square plus bx plus c equals to 0, we get a equals to 1, b equals to minus p, c equals to minus q. Okay. Again, comparing this given equation, x square minus px minus q equals to 0 with this general form of quadratic equation, ax square plus bx plus c equals to 0, we get a equals to 1, b equals to minus p and c equals to q. Therefore, alpha plus beta that is sum of the roots equals to minus b by a, imply alpha plus beta equals to minus b means minus p or a means 1. So this imply alpha plus beta equals to p, and alpha into beta equals to c by a, that is c means minus q and a means 1. This imply alpha into beta equals to minus q. So alpha plus beta becomes p and alpha into beta becomes minus q. Now we have to use these two values. Since a cube plus b cube is equals to a plus b whole cube minus 3ab into a plus b. Now we can use this identity here. So we get alpha plus beta whole cube minus 3 alpha beta into alpha plus beta whole divided by minus q cube. So alpha plus beta means minus q, sorry, plus p. P cube minus 3 into alpha into beta becomes minus q, and alpha plus beta is p whole divided by minus q cube. This implies p cube plus 3pq whole divided by minus q. So we get minus of p cube plus 3pq whole divided by q. So okay, this is a different kind of problem where there is no direct form. That means here we have to find the value of this thing, and when we want to find the value of this kind of problem, then we have to follow this special procedure. This why this procedure is special. Now this procedure is special because to find this value we have to do some different arrangements, and here the arrangements are when roots are known, like in this problem alpha and beta are the roots of this given quadratic equation. So when roots are known, then with the help of that root we can create some special form. Here we create this form, that means we can easily replace this p minus alpha by minus q by alpha, and then p minus beta by minus q by beta. And after replacing these two values by this way, we get this simplified form. And when we know this simplified form, then with the help of these conditions, that is alpha plus beta is equals to minus b by a and alpha into beta equals to c by a, we can easily find the value of alpha cube plus beta cube by following this identity. Okay. In problem number 3, we have a not equals to 0 and this quadratic equation. Okay. So in problem number 3, we have a not equals to 0 and we have to find the value of c when the roots of this quadratic equation m square x square plus 2 into mc minus 2a whole into x plus c square equals to 0 are equal. That means when the roots of this quadratic equation are equal, where a not equals to 0, then we have to find the value of c. Solution: given m square x square plus 2 whole into mc minus 2a whole into x plus c square equals to 0. A not equals to 0. We have to find c when the roots of the above quadratic equation are equal. Okay. Comparing the given equation with the general form of quadratic equation ax square plus bx plus c equals to 0, we get a equals to m square, b equals to 2 whole into mc minus 2 small a, and capital C is equals to small c square. Okay. So since small a is present in the given quadratic equation, we choose the general form of the quadratic equation with the help of this capital A, B, C. Okay. So comparing the given quadratic equation with this general form, we get capital A equals to m square, capital B equals to 2 whole into mc minus 2 small a, and capital C is equals to small c square. Okay. Since the roots of the given equation are equal, therefore discriminant equals to 0, imply D equals to 0. Already we know discriminant means b square minus 4ac. So b square minus 4ac equals to 0. So this imply b means 2 whole into mc minus 2a. So this is b square minus 4 into a. A means m square into c. C means, capital C means small c square equals to 0. So whole square of this will give 4 whole into mc minus 2a whole square minus 4 m square c square equals to 0. So 4 is the common factor of these two terms, this and this. So after taking 4 as the common factor, we get 4 whole into mc minus 2a whole square minus m square c square. This equals to 0. This implies Now this is like a minus b whole square, or so by using this identity a minus b whole square equals to a square minus 2ab plus b square, we can write this as mc whole square minus 2 into mc into 2a plus 2a whole square minus m square c square equals to 0 by 4. When this 4 goes in the right hand side, then we have 0 by 4 in the right hand side. This imply m square c square minus 2 into mc into 2a will give 4 amc. 2a whole square will give 4a square, and then m square c square equals to 0 by 4 means 0. Cancelling these two, m square c square, we get minus 4amc plus 4a square equals to 0. Okay. So since the roots of this given quadratic equation are equal, so discriminant of this quadratic equation is 0. That means b square minus 4ac is equals to 0, and simplifying this we get minus 4amc plus 4a square equals to 0. Okay. Here we have to find the value of c. That is why we can keep this c containing term in the left hand side, and in the right hand side there will be minus 4a square. So c is equals to minus 4a square whole divided by minus 4a into m. This minus when multiplied by another minus in numerator and denominator both, we get plus. Cancelling this 4 and a from numerator and denominator, we get c is equals to a by m. Okay. So this is the way by which we can find the value of unknown. Here that unknown is c. Okay. So in this class we learned about these three different kinds of quadratic problem. Okay. In our next class we will learn more problems depending upon the roots, depending upon the nature of roots of a quadratic equation. Okay.